Okay, so in the last class we stopped at power set. Do you remember what was the power set? Like all the elements from the given sets are called power set, and we can find the cardinality number of from the 2n rule. If there is a set having two elements, so you can say total elements 2 raised to power 2, that is 4. Now these joint sets, when two sets are like here 1 2 3 and 4 5 6, what you are observing? No common elements. So when there is no common elements, we will say both sets are disjoint. This is the symbol for the intersection. So the intersection of disjoint sets are empty sets. It means nothing is common there. Then only thing coming in common is their emptiness or empty sets, right? Now overlapping sets. So when two sets are overlapping, so at least one, it doesn't require that all the sets need to be there, then they become the equal set. So overlapping is when at least one element is in common. Overlapping sets have a non-empty intersections, means they have something common, right? Complement of a set. So universal set we studied previously, that all the possible elements that can make the sets from a given universal sets. So all the elements which are not part of the universal set. Suppose we have given a universal set 1 2 3 4 5, right? So A is here 1 2. Okay, so 1 and 2 is the part of this universal set, but when we will do the complement of A, we will take all the elements that is not part of the set A, but that should come from the universal set here. So key point is union of A and the A complement, which should be the universal set, and intersection of A and the complement A should be the null set, right? So it's very clear. So whatever the rest from the set is considered under the complement. You can represent it by A dash comma, you can give it an AC. So these two way you can represent the complement of a set. Intervals as subset of R. So closed intervals, open intervals, how we will understand that? So closed interval is the set of real numbers such that x lies between two given numbers A and B, including the endpoint A and B. So here you can see we can use this big bracket A comma B for our closed intervals, right? And you can see here this is our set builder form. So x belongs to the real number and x is greater than and equals to. So this equality is including this one. So therefore we are using this bracket, right? So A and B are included in here. All the real numbers satisfying between A and B as well as A and B itself. So both A and B with the part of interval. This is why it is called closed intervals, and we are using the brackets this way. Big bracket are used to indicate that the endpoints are included, right? If you want to understand it from the little representations, graphical representation, you can see this line. So this is blackout, 2 and 5 are blackout here. Why? Because 2 and 5 are already included in, right? So this is represented as the closed interval. Open interval, everything is same, but what you are seeing here that A and B are not included because they are not equal to x. So x cannot be equals to A, x cannot be equals to B, x can be anything between A and B. So this is satisfying all the between conditions. So not included, A and B are not included. So endpoints are not included, right? So they are open interval. We use this a small bracket for indicating the endpoints are excluded. So in our closed brackets, we are using the big brackets to show the inclusion, and here is excluded, so we are using the parenthesis, a small bracket, like 2 and 5. So it means 2 and 5 are not included. If something is saying x belongs to 2 comma 5, what does it mean? It means that not 2 and 5. All the numbers between 2 and 5 are part of the x. So graphical representations, you can say that here is hollow dots, not the filled one. Like in the previous one, what we have, this completely filled one, but here it's not filled, it's hollow dot. So it's saying that it's exclusion. Okay. Now you can use the semi-open and semi-closed. because we have different symbol to represent the boundary condition. So a semi-open or semi-closed interval is set of real numbers such that one endpoint is included and the other endpoint is excluded. These intervals are denoting using a combination of square brackets and parentheses. So big bracket or a small brackets you can use. Combinations like here, A is included but B is excluded. So X belongs to R but X is equals to and greater than A but it's less than B. Whereas in this one, A is excluded, B is included. So you can see we are using the big bracket, right? A square bracket inside of the B. So this is their representations. You can see 2 is included. So 2 is blacked out here, completely filled, but 5 is hollowed. Here also you can see 2 is blacked out, and infinite intervals is a set of real numbers that extends indefinitely in one or both directions. Okay. So if do not have given here, like suppose your condition is not given, but the next portion is, so X is simply saying greater than equals to A, but there must be limitations after A, you are going up to infinity. Similarly, X is greater than A, so you are going up to infinity. But what the difference here? A is included here, so you can see that A uses the square bracket, but here in this condition X is greater than A, so we are going from open interval of A to the infinity. Same for the negative portion, X is less than equals to B, so how much less from the B? From B to the minus infinity. Minus infinity is excluded because we cannot include the infinity. We don't know that what is the infinity point there. Similarly for the open bracket, but here B is excluded. Here we are using the closed bracket. So here B is excluded up to the minus infinity. And when simply saying X belongs to a real number, so real number means minus infinity to infinity. So wherever we see that X belongs to infinity, this is a symbol of belongs to. When you will see the graphical representations, you can just keep open the all directions. Any numbers, dot dot dot, it's open, right? So this is our minus infinity, this is our plus infinity. So both sides are open. This is our real number intervals. Okay, so we will do the Venn diagram in our next class. For today we are putting it here. Okay.